a PhD in operational research from the University of Edinburgh. He has previously worked at KTH Royal Institute of Technology Sweden, Technical University of Denmark, and the University of Copenhagen. Waqquas is a fellow of the UK Higher Education Academy and a senior member of IEEE. Today, in his talk, he will share his journey from studying a BS in mathematics at COMSATS to working alongside electrical engineers and how he had to develop models that support the efficient operation and planning of electricity systems. Thank you so much, sir, for having us. Please continue.
Gee, Shukriya, Nimra. Thanks very much. That was very kind. Thanks all for joining. I can see a few participants in the audience, which is great. In this talk, I'm going to talk about two things. First is my journey from studying BS in mathematics, how I ended up in an electrical engineering department. That's not usually a career path which a mathematician would take. And secondly, I'll talk about the importance of mathematics in the sector which I work. I'm aware that most of you would have nothing to do with the research in power systems, or I'm hoping that you'll be able to draw some parallels between my experience, the kind of synergies, the type of problems which I deal with in the electricity systems, and the kind of the sector which you are working in. Like this session to be a little bit interactive, and the way we can do is by Mentimeter, but we don't have a large pool of audience, so we'll see how that goes. So I thought that I'll just have a feel of what the mix of audience is, whether there are more bachelor students, master students, or staff members, and also have asked a few questions about just to get your thoughts about a few questions which we'll come on to in a little bit. So we'll see how that goes. Also, just before I get started, if at any point you have any question or anything which you are unsure of, just drop that in the chat if that works. If not, just use the raise hand button and I'll come to you. So just don't hold off saying anything which comes to your mind. Right, so let's go. What better way to talk about your journey than a timeline? I apologize, it's the years on the x-axis, they are not very mathematically precise, so I hope you'll forgive me for that. Yeah, as Nimra said, I did my BS Mathematics from COMSATS in 2008, and over the last 20 years or so, I have ended up in the electrical engineering department. So this slide is just trying to show how I got from where I was to where I am. So BS in Mathematics in 2008, I have assembled some pictures for your amusement. So these are the pictures from our, I believe in somewhere in Murray, as they say, Mulla ki Daud Masjid tak. So if you are based in Islamabad and Rawalpindi, where would you go for a day trip? Highly probable that it's going to be Murray. So we used to go to Murray. That used to be a highlight of our academic year. So after graduating, I went on to MS leading to PhD at LUMS. I didn't stay there very long, spent about 6 months or so at LUMS. And then I moved on to take up a researcher's position at KTH. I hope you can see my cursor here. So this picture is presenting the research I did at KTH in LUMS. And there was a lot of time doing fun stuff in LUMS as well. So while I was at KTH, I secured a PhD position to study operational research at Edinburgh. And here you can see a picture of me and my wife. We submitted our thesis at the same day. And a few months later, we graduated. So Edinburgh was great. That's where I developed the kind of rigor. After my PhD, I moved on to do my first postdoc at DTU, which is Technical University of Denmark. After 2014, I moved back to Scotland, started working at the University of Strathclyde. Right. Okay. So that was a very brief, very quick overview of my journey from moving from maths, from BS Maths at COMSATS to Strathclyde. So let me just say a few words about my time at COMSATS. As I said, we were the third cohort of BS Mathematics. And one of the challenge when coming in to do a BS Mathematics was that we didn't have any precedence. One thing you look at is kind of what the graduates are doing or have done. And at the time, we didn't have that precedence. We're coming in, taking the risk that, okay, we don't know what that would turn out. Few of the teachers, which I remembered, you might be aware of Sir Abdullah Shah, was one of the reason I joined the BS program. My father and I went to the maths department just to see before I joined that what's it all about, and we bumped into Sir Abdullah Shah, and then he said that why you want to do engineering, come and do maths, and you can always go back and do engineering, and that turned out to be true. Sir Mansoor Ahmed, I believe he's still COMSAT, gave me the opportunity to lead, made me a CR, and very own Sir Sohail Iqbal, who taught us, I mean, as we were speaking, linear algebra and discrete mathematics. And one of the things which I have took away from those courses were the methods of proof. It really struck me that how powerful a theorem can be. You have to make many heroic assumptions to prove it. And often those assumptions does not hold in practical life. But what you get towards the end, it's very powerful. It's beautiful. That it's kind of a journal truth. And my final year project was with Sir Aslam Noor, looking at kind of what we call G convexity. And yeah, I mean, that's where I was introduced to the research, how to write a report, how to actually prove things, and so on and so forth. Assembled some just for your amusement here. So this is a picture which I stumbled across. You might recognize two of the faces. The other two pictures are at some random fuel station on the way to Murray. Traditionally, we used to take the dholwalas. And finally, that's my cohort, all my colleagues and friends, and picture. The picture you see on the bottom left, that's our graduation. I thought that I wouldn't do justice if I don't talk about things which I thought could have been better. And here are the three things. At the time, I realized that there was a lot of focus on how to do things. And there was not so much focus on why. And I believe that's still the case, which I personally think needs to improve. And second and third are that there was not much mathematical rigor, and there was not kind of a structure to the whole program. I hope, I mean, as I said, it was early days in BS Mathematics, and I hope that has improved. Right, fast forward 20 years. These are my colleagues who I work with. I'm not going to dwell too much around each project, but generally what we are trying to do within the research group is trying to build mathematical models. And using those mathematical models, we try and gain insights into ways to improve system operation. And one of the things which our research is motivated is about having real world applications, that our research translates into something which makes a difference. In this slide, I'll talk a little bit about the impacts we have to date. And in terms of academic research, you could have impact in different ways. For example, when you write and publish papers, that's impact. How useful it is, it's another question. So in terms of impact, one of the biggest or the main impact to date is our open source modeling tool, which is called OATS. So on the basis of building these mathematicals model, we have had real world impact, which has been quantified. So one of the things which Nimra in the introduction talked about is called bulk dispatch optimization. This is a picture of our electricity control room in Great Britain. And this bulk dispatch optimization developed at Strathclyde is in use at the control room, and it's saving approximately £15 million a year. The tools which we have developed are in use by 3 different transmission system operators in the world. Elia is the Belgian transmission system operator, NISO is the British operator, and I have done some work with NTDC, the system operator in Pakistan. And of course, this work has influenced a number of academic publications and technical reports where people use these models to evaluate, to quantify the benefit, whether it could be of new investment in generation, use of a particular type of flexibility, a service. Right, so that was kind of the work, the first part of the talk, if you like. Let me go into the next part, which is more focused on the relationship between mathematics and electricity networks. And then the 2 things which I'm gonna talk more about is what does it take to keep the lights on? And secondly, I'll talk a little bit about the role which maths play in keeping the lights on. So just to explain to you that what it takes to keep the lights on, here is a electricity generation map of Pakistan. Most of you would be based somewhere here around Islamabad. We have got a lot of hydro generation in the north of the country, right? So where you see these solid.
Where are you getting all this data from about Pakistan?
This is from a source which is mentioned on the slide.
Okay, thanks.
Welcome. And we have got more thermal generation centered around the demand center. So big population areas, Lahore, Faisalabad, Multan. And then we have got nuclear in Chashma and also in Karachi, and increasing capacities coming in Chashma. Our demand centers, our generation centers, you can think of them as nodes. And the light blue lines which you see there are transmission lines. So these are high voltage transmission lines which connect generators to demand, and power flows from generators to demand, right? So what I'm trying to say is that you can think of this as a planar graph. So we have a way to represent an electricity network in kind of more graph theoretical setting. And once we have got a graph, you know, all the algorithms, the least distance and things like that, which goes along with that. The question, what it takes to keep the lights on is, it's particularly challenging for electricity networks. The main reason is that we don't have large amounts of electricity storage in the system. In gas networks, we have got pressure, which you can control. In telecoms, we have got some buffers. But in electricity networks, we don't have those degrees of flexibility, which means that if your electricity demand has to increase, it needs to be met by real-time redispatch of a generator. Literally, if you were to switch on a bulb or a large load, it needs to be met by an increase somewhere in the country. To delve a little bit more deeper into the electricity network, I need to explain 2 fundamental concepts. And those concepts are of a model and optimization. So model, you know, it's a simple representation of the system, simple enough to analyze, but adequately complex to capture key aspects. Some examples of model, we have got a British electricity system. We can represent that with a reduced graph. Here is the European electricity system. Again, we can represent it with a simple representation. There are certain assumptions which go behind it. Most of the work which I do is an electricity network, but the methods, the techniques which we use are transferable. Here is a picture of a building I used to sit in. a few years ago. It's in the shape of a triangle. During COVID, I tried and modeled it. So it's a 2D projection. If you are looking down, if you zoom in, you'll see a seating plan. And the problem I was interested in was during COVID, we had these physical distancing constraints. So if you are sitting in a closed building, you must be 2 meters apart from each other. So I was interested in if you were to apply a 2-meter physical distancing, how many building occupants we can accommodate. So I'll show you results in a minute. So yeah, so these are examples of models. And then when we have got more trendy things like neural networks, which have multiple layers, and large language models, which are taking the world by storm. If you lift the hood and look a bit more carefully how things are working in these models, they are, in fact, in simplest term, they are a function. So you have got a function, you stick in some input, and what comes out is output, right? So that's the purpose of a model. Optimization, on the other hand, is much more than simply a model. It's the layer which sits on top of input, model, and output. And the question you want to ask is, what I can do to make the system as best as I can, as good as I can. Relating back to the models, I showed you the first model, which is a representative GB model. We asked a question that what investments are needed in the network to make it compliant. It's not important for this talk is that what exactly the nature of the problem was, that giving a message that we can use that model and optimize it. For the European model, we asked the question that if Britain were to interconnect with mainland Europe, that increase its transmission capacity or build new interconnectors, what economic benefit that would give to Britain. You can ask a similar question that if Pakistan were to interconnect with India, for example, there is no kind of electricity interconnection, what benefit that would provide it to the consumer on both ends. And finally, for something completely unrelated on social distancing, you see that when there are no social distancing constraints, you can get 100% occupancy in a building. And when you reduce that constraint, when you increase your social distancing, it decreases in a nonlinear fashion. And actually, it's about less than 40% occupancy you can get with 2 meter physical distancing. The takeaway message from here is that models and optimization can be a very powerful way to convey, to quantify benefits and to make decisions. Let's take this into a little bit more mathematical context. So in its simplest form, an optimization problem can be posed as follows. You have got a function which you are trying to minimize. This function is of x and y. So x and y could be variables, they could be vector, subject to set of constraints. So we have got an equality constraint, an inequality constraint, and then certain bounds. So x lives in a Euclidean space, or in a set which lives in a Euclidean space, and y are integers. So as I said, that's an objective function, and that's the set of constraints. So the model is within the set of constraints. Objective function is what you are trying to achieve. And depending on the nature of your objective function and constraints, this optimization problem can take different shapes. So it could be linear, nonlinear, discrete, so on and so forth. What's the relationship of optimization problem to the electricity system problems which I'm interested in? So the kind of objective function we deal with is operation cost. So generators, electricity generators, they have mainly a fuel cost traditionally, whether they are powered by coal or natural gas. There is investment cost. So if you are doing a long-term planning optimization problem, you're interested in minimizing your investment cost to meet predictive demand. And then cost of unreliability. When lights go off, there is a huge economic cost, which is to people, to industry, so on and so forth. So in terms of constraints, we have got Kirchhoff's laws, which actually are laws which govern the flow of electricity, capacity constraint, voltage limits. We want the system to be stable, so there are stability constraints. I'm not going to delve too much into the details of how the mathematics of Kirchhoff laws and think is not very relevant, but just to give you a feel, the two equations you see at the very bottom of the slide, they are nonlinear equations which govern the flow of power in a transmission line. And whenever there is a nonlinearity, that problem becomes more challenging to solve. This is a journal form of optimization problem where you're minimizing a function subject to all the constraints. Again, don't worry if this doesn't make much sense. The point here is that the optimization problem in electricity networks are challenging. They are quite difficult to solve. I hope, what I have said in the last 5-10 minutes, it has made some kind of sense in terms of relating the importance of mathematics or the role of mathematics in electricity networks, how we are trying to model them. So next I'm take you through a couple of case studies, one in system operation and one in system planning, just to bring home the kind of the message that, okay, so we can model the system in a mathematical context, so what? So these case studies will answer that question of, so what? Right, so the first case study I'm going to talk about, which I mentioned briefly earlier as well, is about real-time balancing. And here is another picture of the electricity control room in Great Britain. That's where the control engineers ensure that your system is balanced in real time. So generation is equal to demand. Traditionally, they used to do it in a manual manner. So each control room engineer would instruct a generator to move up or down to meet that demand. And there are a lot of changes which are happening within a system, mainly driven by more renewable generation, more wind, more solar in the system. And with the targets which the UK government has set out for itself, having a decarbonized power system by 2035 and a net zero energy system by 2050. So the solution to that is automation. Automation essentially means to free up human resource. So rather than human operators actually manually instructing, we give them a capability to sense check the results. So we'll have an automatic system which will give you advice. So that's what we have done in this particular project. And just to show you the impact of that on number of instructions. So you see where my cursor is, the level of instruction, the number of instructions to, and the increase after this tool has been deployed at the control room. Here is a link to a paper, goes into a much more detail into this particular case study. It also includes the mathematical model, the particular constraints which we had to implement within that tool. Right, so that was on balancing. And second example is more closer to home. So it's about investment planning in Pakistan. I think I don't need to explain too much about the challenge which electricity system faces in Pakistan. So we have got one of the most expensive electricity tariffs in the region, a very unreliable supply power. Over the years, 2-3 decades, I think Pakistan has done well in building generation capacity, not the right type of capacity itself in terms of gigawatt. So we are in a situation, we have got enough capacity, but we don't have enough transmission to transmit that generation from where it's based to where it's needed. And so I happen to work with NTDC, which is the transmission system operator in Pakistan, and trying to build an optimization model to provide them with the capability to inform that what transmission options should be considered. So here are a few pictures from last year. I went to spend a few days at the NTDC offices in Pakistan. So with some of the colleagues who are very close to the real-time operation of the system. So these are the people which keeps the lights on in Pakistan. Here is a reduced model which was provided by the NTDC colleagues. So this is our representative model. It's not a detailed model. So few nodes you can see. And my contribution to that project was trying to project that model into future and ask a question that, okay, what transmission investment options should be considered? So where we should build the line, or if we are building more generation, what impact that would have on consumer benefit. So here you can see a model and an animation here, which is a result of, is for a particular case in 2030, these will be the expected flows. And these numbers mean something in the background. So there is a deficit of power there or a surplus of power. So the point I'm trying to make is that once we have a model, we can try and optimize it to get some useful information out of it. And since this is a planning problem, it's looking ahead. There are a lot of uncertainties in what the demand would be in 2030. So we need to simulate a very large number of scenarios. And the tool which we have built through this project actually allows us to simulate a very large set of problems. So then we can play different tunes. So what if there is no K2 or K3 in 2030? So two of the generation plants, they don't materialize. What impact that would have? Or if the wind is not blowing and sun is not shining, what impact that would have on our electricity network? That brings me to my last slide. What does maths have to do with electricity? I hope you'll agree with me now that it has to do a lot with electricity. When we can model power flows using these mathematical equations, we can optimize electricity models. We can do uncertainty-aware optimization, look into much future and then try to simulate things. Stability, something which I haven't talked about is the kind of the swing equation which you do in your a course on ordinary differential equations. That's the same model which is used to study stability in power systems. And also in networks, and then trying to decide which new lines to build, so on and so forth. As I said before, while I have focused mainly on electricity, that's the sector I work in, but you can use the similar techniques and apply it into different problems and challenges. For example, we have got very severe flooding in Pakistan at the moment. So you might want to ask a question, okay, how the water would flow, what lines it will take, can we do something to divert it? You can pose that as an optimization problem. After flooding, we might have a problem with infectious diseases. And then you can again pose this as a problem that how malaria or other diseases will spread. What can we do to put a firewall around that? So if you have to take one thing away from this talk, I'd say that would be the punchline that maths gives you wings, with an apology to Red Bull. Maths gives you wings. I mean that it takes you beyond one subject. I think that the best thing which maths has enabled me to do is to make a real world impact through the research which I do. Thanks very much for listening to me. I hope you are all still with me. I wasn't speaking to my computer screen. I'll stop here and I welcome any questions that you might have.
Ji, thank you, Waqquas. बहुत अच्छी टॉक थी और हमने बहुत सीखा। जी बच्चों, एनी क्वेश्चंस? Any questions from the audience?
Either I have made everything very clear or it didn't
It was
make sense at all.
No, it was a very, very, very accessible talk. So I think they are all clear what is happening. ओके, तो आप इलेक्ट्रिसिटी के साथ ही ओवरऑल शुरू से काम किया या किसी और एरिया में भी आपने इसको अप्लाई किया? जैसे आप कह रहे थे कि कोरोना में तो आपने वो एक चीज की, लेकिन इसके अलावा किसी और इंडस्ट्री में इसको देखा आपने?
नहीं सर, मैं इत्तेफाक नहीं हुआ मुझे generally to do some deep work in any other industry. Shokia, I did a few small side projects just for the sake of amusement. So one was that looking at the social distancing. Another thing which I looked, there is a difference when you convert Danish kronas to British pounds. And that difference varies over the year. So I thought of putting a model where you can have a look ahead perspective. You try and optimize to make money that when you invest in Danish kronas or British pounds. But that didn't go much further. I have also tried and put some portfolio optimization models just to inform that which stocks to invest in. That's an area where you're guaranteed to lose money if you were to follow advice from these kind of portfolio optimization models. And there are certain reasons why they behave the way they like.
Because there are many parameters, or there are many factors, or something else?
Because of the uncertainty. You never know what Donald Trump or Elon Musk or Narendra Modi or Shehbaz Sharif is going to say, and that's going to have a direct impact on the price of stocks. So you cannot build you can try and build a model, but because there are so many degrees, so many vectors and uncertainties around that, that it becomes almost impossible. So then the journal advises that invest in something which is kind of a robust stock and diversify your portfolio. So if you are taking a hit from one side, it's balanced by something else.
Okay, good.
But I mean,
Nice.
as I said, financial sector is just one area where optimization or modeling finds application. There are other sectors as well. Healthcare is another example. Transportation is another. Well, timetabling in universities, I looked at those problems as well. So you have got students, limited resource on rooms on the campus. So how would you allocate your classes to the rooms?
I think timetable in particularly in COMSATS, it's more like a stock exchange problem rather than a transport problem. Okay, Waqquas. Ji.
Did you still do morning and evening shifts?
Yes, we have morning and evening shifts, and
okay.
Now the classes are open on Saturdays as well. क्योंकि कुछ rooms थे वो बारिश में थोड़ा खराब हो गए.
Okay. अब तो हालात मेरे ख्याल बेहतर होंगे जो H8 से bigger campus and more resources, I would imagine.
Relatively. वकास, अगर यहाँ पे कुछ स्टूडेंट्स हैं और ये रिकॉर्डिंग है तो बाद में काफी ज्यादा स्टूडेंट्स सुनेंगे, क्योंकि अभी अक्सर लोग 5:30 क्लासेस खत्म होती है तो वो ट्रैवल भी कर रहे हैं, तो ये टाइम चेंज की वजह से लोग कुछ कम है। लेकिन ये जो लोग सुन रहे हैं उनके लिए आप कुछ बताएंगे कि if someone wants to follow your path and in this area, what would be the advice?
I'm sure that you'll choose your own destination. As I said at the beginning, please do draw parallels with what I have said. There would be some things which you can relate to. In terms of advice, life is a marathon. It's not a sprint. Generally, I couldn't get that Menti meter to work, but I'm assuming that most of you are in bachelor's or in master's. So when I was at your stage, I was worried with GPA, CGPA, things like that. And I think it would be the same for you. But in the long run, it doesn't matter that much. What matters is that how good your understanding is, and understanding of fundamental concepts. And I often say to my students that a good understanding of sets and functions is a prerequisite to study anything built on mathematics. So my advice to you would be to work on your fundamentals. And second thing, do try and talk to or work with someone which can give you a perspective of kind of a bigger picture, which has gone through that process, and then that perspective is very useful. I have been lucky to work with people who have a kind of a firm understanding of the area, of the subject matter, and that has been very useful in terms of guiding the kind of research I did or the type of questions I'm trying to ask. I think bigger picture is important. So yeah, I don't know. I hope that be kind of useful advice in terms of working on your fundamentals, not worrying too much about the minor details, and then having a kind of a bigger picture.
Okay, आप अभी यूके की एकेडमिया में हैं. So what kind of opportunities are available for the current undergraduates or postgraduate MS completed students?
In terms of academia, if you want to come to UK for further studies, UK has got lots of universities and some good universities as well. In terms of opportunities, in terms of scholarship, it's becoming very challenging in the sector because there is not much resources or funds available. Of course, there are kind of standard grants, Commonwealth scholarship, or university-sponsored studentships, things like that. So अगर आप आना चाहते हैं masters के लिए, typically it's 1 year masters. UK is traditionally it has been very expensive and it has become more expensive now. And the scholarships are far and few. So, I mean, I think self-funding is one option. Scholarship, if some is available, it's very competitive. So that's not a very encouraging or promising news for somebody who wants to come and study for a master's. For PhD or for a postdoc even, there are certain opportunities which are publicized. So, I mean, show that how you are relevant to that position or how you can contribute. So in terms of that, आपके लिए जो आप अपना project कर रहे हैं final year, whether it's bachelor's or master's, that could be a really good selling point अगर आपने इस particular project से related कोई मतलब आपने research की हुई है जो project किया हुआ है, that would add a lot of weight to your application. What makes a difference is that how you can demonstrate that you are capable. And again, if you can demonstrate that you have got strong fundamentals and a deeper understanding of the area, bring parallels, relevance, I think that would put a lot of weight to your application. I mean, things are tough, but they were tough 10 years ago as well, 20 years ago as well. So don't let me discourage you. You have to be in it to win it. So apply. नहीं होगा तो कोई बात नहीं.
Sir, I have a question.
जी.
Sir, can we contact you regarding further guidance in future?
Ji, of course. I'm happy to do any kind of a structured meeting like जैसे आप अभी कर रहे हैं. Individual emails, I might be able to reply, I might not be able to reply. So it depends on whether I can offer some useful advice or not. Sometimes I know a little bit about a particular field, but kind of this area is quite wide. So I cannot promise to answer every email, but if there is kind of any structured feedback session you want, I'm quite happy to do that.
चलिए, I think यहाँ पे once again या स्टूडेंट ट्रैवल कर रहे हैं क्योंकि 5:45 पे अभी 6:24 हो रहे हैं शाम. 5:45 पे बसेस चलती हैं, वो फिर अक्सर ट्रैवल ही कर रहे हैं बसेस में. लेकिन इट वाज अ वंडरफुल टॉक. थैंक यू वकास, वेरी इंफॉर्मेटिव. और कैसे ये ग्रेड ये जो प्रॉब्लम्स हैं और इस किस्म की चीज़ें वो कैसे करते हैं. इट्स वेरी इंफॉर्मेटिव. थैंक यू.
Thank you, sir. It took 20 years to talk to you. I hope कि हम अगली दफा इतना टाइम नहीं लगेगा.
इंशाल्लाह आप बस दिसंबर का प्लान करें फिक्स है. ये इन लोगों ने लिख लिया, अभी आप लोगों को कांटेक्ट करेंगे. कुछ हमारी आईटी की टीम है, साथ हैं, और कुछ वो बाकी लोग हैं जो पोस्टर वगैरह मीडिया वगैरह देखते हैं. तो
ठीक है सर.
Thank you very much, Waqquas. Once again, it was wonderful, listening to you after so much time. So,
जी सर, thank you for having me. शुक्रिया सबका अटेंड करने का.
ठीक है.
Thank you, sir.
Your path was very inspiring. And very well said. It's a marathon. To focus on the bigger goals. So well said.
Okay.
Thank you. Thank you for coming. Yeah.